So here's the second part of 6.1 that we're going to go over. And so it's called exponential growth and decay models. So we've talked a little bit about growth and decay. You know that if the number that is to the power, the x power, if that number is bigger than 1, it's going to be a growth. If it's between 0 and 1, it's going to be a decay. And so that's what this kind of talks about with these exponential growths. If you're talking about money and your money's going to exponentially grow, and you say it's going to grow at 50%, then it's not going to grow 50%, meaning you're only going to have half of your money. You're going to have the original amount that you had plus 50% more. That's where that 1 comes in. The 1 right here, this 1 right here, is you keep your original and you get another 50%. So that's why that 1 has to be there. So this is just going to be our equation that we're going to use. So this is going to be the equation that we use over here for gross. And this is going to be the equation that we use. And if you actually do the 1 minus, it turns into what we were doing yesterday, where it's just y equals some number times another number and then to a power. Right? That's what we did yesterday. Well, once you do the 1 minus r, it will turn into this number here, which will tell you whether it's a growth or decay. If you're doing the 1 minus, it's going to be a decay. If you're doing the plus, it's going to be a growth. So that is what we're going to talk to today. And then you're going to have homework based on that. So a car was purchased for $24,000. A function y equals 24 times, so this is the original amount. That's the initial. Times 0.8 to the x can be used as a model of the value of the car in thousands. That's huge. So they cut this 24,000 to just a 24. That's because we're talking about in thousands of dollars. X years after it was purchased. So does this function represent a growth or decay? So we are going to look at this right here. We're going to look right here at this number. If that number is smaller than 1, then it is a decay. If it's bigger than 1, it's a growth. And so since that's smaller than 1, we would call this a decay. What is the rate of decay for this function, and what does that mean? Well, this 0.8, when that 0.8 means that that car is going to be worth 80% of its value each year. That's how much it's going to be worth, 80% of what it was worth the year before, which means its decay rate is 0.2. The way I got that is you take a 1 and you minus the 0.8, and that gets you your decay. And what does that mean? It means that that car is losing 20%, right, move the decimal place, 20% of its value each year. Each year that car is going to be worth less than it was the year before. It's going to be worth 20% less. So if it was worth 100 the first time, it would have been worth 80. We're just doing $100, nice and easy numbers. Then it would be worth 80. And then you would do 20% of 80, and that's how much it would be the next year. All right, so keep going on. The population of a large city was about 4.6 million in year 2010 and grew at a rate of 1.3% for the next 4 years. What exponential function models the population? So if we remember, this is a growth, right? It's a grew. So it's going to be y equals a, which is our initial, whatever we started with, a times 1 plus r to the t power is what we used. So we're going to fill in all these things that they gave us. The a is the initial. Well, what did it start at? It started at 4.6 million. So this is going to be 4.6. 1 plus, we can't use this as a percent, so we don't want to use that as 1.3%. So we're going to put that back here, and that's going to become 0.013. So we're going to add that. That's our R. is the 0.013. You have to change it to a decimal, and then we're going to leave t. So there's our equation that we're going to use for that. And you can see it explained right here. And this is years since 2010. So it's a little strange because if we're talking about 2012, so 2012, if I want to know how much it would be, my t would equal 2 because it's been 2 years since 2010. If I wanted to talk about 2019, then that would be my t would equal 9 because it's been 9 years since this time. All right, so last thing we're going to go over, if the population continues to grow at the same rate, what will the population be in 2040? So be using the formula we just came up with, or the one that's currently right here, except now instead of this t, since I'm going to 2040, that would be, my t would be 30 years. So I'm going to do the population is 4.6 times 1.013 to the 30th. And in my calculator, I'm going to put 1.013 and the caret. So in my calculator, I'm going to do this. And I'm going to hit equals. That will give me some number. I'm going to hit times. So that number right there, I'm going to leave it there. I'm going to hit times 4.6. And if you do that, you should get 6.78. But remember, that's in millions. So that's 6.78 million, or 780,000. That would be the real answer of how many people. Okay, so I hope that makes sense. That should be enough for what you need to get done for your homework tonight. And I told you we're going to try to keep them simple and quick. Make sure if you have any questions that you come and see the homework. There wasn't many of you who joined that, so I'm hoping that we start using that a little more. I have that homework help, and I'll tell you when I'm going to be going live on there, and you can come and ask any questions about this, or even questions about the teams and all that. Teams is still very slow. I'm going to try to upload this video. It might not work, but it will be on YouTube. And if it doesn't work on Teams, then we'll be still using Portal or Focus and YouTube. YouTube to watch it, then Focus to upload. But really, I don't care about that stuff as much as I care about you understanding the content. That is my main concern. So I hope you're having a wonderful Wednesday. This is, and we will see you soon.